Hey y'all, today we're going to go through 2.4 library of functions and talking about the piecewise function. So here is just our square root function, the domain, the range, and like its properties. So we're going to look at this first example and go through basically those steps and determine whether the cube root is even, odd, or neither. Then determine if it has any intercepts and then determine the properties of the function. So the cube root function, we can graph it on the HB prime, or we can also, we're going to graph it by hand. So we have first to determine if it's even, we're going to plug in that negative. So negative x, and this equals negative cube root of x. That doesn't equal the original function, so not even. Then let's test for odd. So negative f of x, so negative, and then cube. And that does equal what we just got when we were trying to solve for even. So this is odd function. So symmetric. So symmetry over origin. Alright, now we're going to determine the intercepts, if any. So I'm going to plug in 0 for x and find y. And so the cube root of 0 is 0. So our x and y intercept is 0, 0. It goes through the origin. Next, we're going to graph it. So I'm going to need to plot some points and do a table. And so I have my x and y table. I'm going to shrink this to give me more room. Oops. Shrink. Why is it doing that? Okay, shrink. And then move. Alright, that works. So x and y, I'm going to plug in 0, and we know I get 0. If I plug in 1/8, I would end up getting 1/2. If I plug in 1, the cube root of 1 is 1, and the cube root of 8 is 2. So here's some points for us. So 0, 0, 1/2, 1/8, then 1, 1, and then 8, 2. And we know that this is symmetric over the origin, so it's going to look something like this to graph our negative side. And then the properties, so this is increasing, the whole graph is increasing from negative infinity to infinity, and then there's no local max or min. So increasing from negative infinity to infinity, and then no local max or min. Alright, we're going to do the same thing for the absolute value function. So let's test for symmetry. So f of negative x will tell us if it's even. So that's the absolute value of negative x, which just equals the absolute value of x. And that equals the original, so it's even. So we have symmetry over y-axis. I cannot spell today. Okay, so symmetry over y-axis. Alright, next we're going to look for those intercepts. So for our y-intercept, x equals 0, so let's plug in 0. So y equals the absolute value of 0, which just equals 0. So we have the intercept is 0, 0. And then since 0, 0 is our intercept, that means that's both the x and y intercept. Alright, now I'm going to do a table of values. to get some points to do our graph. So let's do 0, 1, and 2. We know when we plug in 0, we get 0. If you plug in 1, the absolute value of 1 is 1, and the absolute value of 2 is 2. So I'm going to graph it. 1, 1, 0, 0, 2, 2. And then since it's symmetric over the y-axis, I'm going to use symmetry to draw the other half. And this function is increasing here from 0 to infinity. So increasing from 0 to infinity. And it's decreasing from negative infinity to 0. And then lastly, we do not have any local maximums. The only thing we have is a local minimum at our origin point. So local min at x equals 0. So local min, and I'll rewrite it differently. So local min of 0 at x equals 0. Alright, and here's just some parent functions that we want to make sure that we know how to graph. So remember to take some time to go over these. So if I do ask you to graph these, you know how to graph those key parent functions. Alright, so we are going to now graph a piecewise function. And so we have this one that is negative x plus 1, and 2 if x equals 1, and then x squared, x is greater than 1. And so to graph this, we're going to graph it in part C. But first we're going to find f of 0, f of 1, and f of 2. So f of 0, if we take a look at our restrictions, so this one is the first one is between negative 1 and 1. So that includes 0. So we're going to use this function to find f of 0. So we're going to plug in 0. So that would be negative 0 plus 1, which just equals 1. Next, we're going to find when it equals 1. So the only time when we're looking at when the function equals 1 is at this second one, because our restriction is x equals 1. And so our y value is 2. So f of 1 equals 2. And then f of 2, we're going to use that third equation because it's when x is greater than 1. So f of 2 is 2 squared, which equals 4. Now we're going to determine the domain of the function, and we see that the farthest left point is at negative 1. So this function is going to start on the very left of negative 1, but on this third one, x is greater than 1, so there's no end point to this one, so it's going to go to infinity. So our domain is from negative 1 to infinity. Now we're going to graph by hand. Okay, so the first thing I'm going to do is graph our negative x plus 1 between negative 1 and 1. I always like to graph the function and then restrict it. So I'm going to start at plus 1 because that's my y-intercept, and then do my slope of down 1 over 1, down 1 over 1, or up 1 over 1. And you can connect your points. And it should look something like this. But we know that this only is between negative 1 and 1. So I'm going to take my eraser and erase all other points that are not between negative 1 and 1. So that only should look like this. Now we need to talk about our endpoints. So it has a closed hole at -1, but an open hole at 1. So I'm going to make just an open hole right there at -1. Next we have 2 and x equals 1. So that just means this is a point of 1, 2. So at 1, 2, I'm going to make a point there. Then x squared. So I'm going to go ahead and graph x squared. And, oops, so that's about here, 2, 4. So about something like this. And we know that that one's when x is greater than 1. And so that's an open hole circle. And everything that I drew before that, I'm going to go ahead and go erase. So this is what our final graph should look like. And now we're going to use our graph to find the range of this function. Again, range is our y value. So this graph has nothing below the x-axis. So that means our graph is greater than 0. So our range is from 0 to infinity. And that's it. Let me know if you have any questions. We'll do some more piecewise functions together in class.